So I'll be conducting an interview with Ben from Axiado. And with that, Ben, or rather Professor Levine, because you have academic background, Carnegie Mellon. I also went to Carnegie Mellon. So yeah, maybe introduce yourself and tell us what's your career's been, the shift from academia to industry. Yeah.
Sure, happy to, Muneeb, and thanks for the introduction. Great to be here talking to you today. I haven't been called Professor Levine in a very long time. It feels like another lifetime ago. I made sort of an interesting shift from academia to engineering leadership to product management and marketing as well. And that's what I do at Axiado in charge of product management and marketing. And at Axiado, we're really focused on making data centers more intelligent, more efficient, more secure and more reliable. And it's been really fun stuff to work on that's brought in a lot of stuff from previous parts of my career and my background in academia. So it's great to be here talking to you about that today.
Of course, fascinating. So when you talk about more reliability in the data centers, what's the biggest shift in the AI infrastructure you're seeing right now?
In terms of reliability, I think part of it is just the fact that we're seeing larger and larger clusters for these big training runs, and also just the size of the infrastructure is scaling out to be so large that when there are failures, the blast radius is really large, and the economic impact is really huge. Companies have SLAs that they're trying to meet, or if they're doing a training run and that gets disrupted by a failure of some sort, it has a huge economic cost. And that's just getting worse and worse as things are scaling up. So what we're trying to do is make data center infrastructure smarter and more proactive so that we can detect and take care of failures before they happen, so that these breakdowns and outages that are so expensive just don't happen in the first place. And if I can add another part of that as well is, things will happen that cause failures. We also are taking a lot of effort to have ways of analyzing failures when they happen. So we have a lot of telemetry that comes into our silicon that we can then analyze and do debug analysis, so that if we weren't able to prevent a failure, at least we can see what happened and take steps so it doesn't happen again in the future.
So there is so much monitoring that already happens in the data center, and there are probably some solutions around it as well. So what is it that Axiado brings, or what's different about Axiado that gives more control over preventing these failures?
Yeah, absolutely. So we do replace what they call a baseboard management controller, which is a chip that sits various places in the AI infrastructure rack, on a server motherboard or a super chip carrier, other components. And these have been around for a long time, and they've been pretty sort of dumb passive devices that just read sensors, take logs, and maybe raise alerts to a human to do something, but that's about it. And we've done a couple of things differently. First, we've integrated a lot of security. So the BMC now becomes a trusted device that can attach sensor data and that can ensure the authenticity of all the components in software in the system. But the really big thing we're doing is we're adding intelligence. So we have AI engines on our silicon that can take all this sensor data that we're pulling in, analyze it, using AI models and agents that we've developed, and detect something that's a problem. It could be a security breach of some sort. It could be an impending failure of some sort. It could just be that we're not using the hardware efficiently. And then because we're at this low level of hardware, we can take action and actually do something. So we're going from just passive monitoring, maybe raising alerts to a human to do something, to actually reading in data, taking intelligent action autonomously right there at that low level of hardware. And that's something that no one else can really do at this time.
Can you talk about some of the failures and how your autonomous actions or the actions you can take can prevent those failures?
Sure. So there's I like to talk about three different pillars of what we do, and I've kind of touched on them before. But again, security, efficiency, and reliability. And these intelligent actions can relate to any of those three. I'll start with the security example, and I'll give a quick one for the other two as well. But for security, we're monitoring not just things like fans and temperatures. We're also monitoring workloads and network traffic and GPU and CPU utilization. And there are patterns in that data that can be indicative of some sort of an attack. Let's say there's anomalous network traffic suddenly to a certain port. we can detect that with our AI agents and say, hey, wait, this is indicative of a problem. And then maybe we will block a port, or maybe we get assigned that a server has been infected or compromised, and we can isolate that server, and we can do that autonomously. So that's a security example. The efficiency examples, there's sort of two aspects to efficiency. One is power efficiency, and for that, we can constantly monitor what's going on in the system and take action to adjust cooling, like fans, to be more efficient and not use as much power to cool the system. But even more impactful is we can change the frequency and the voltage that GPUs and CPUs, which are the components that use the bulk of the power in the server tray, we can adjust those voltages and frequencies to use less power without impacting performance. And we can do that in real time based on the data that we're getting in. And then finally, reliability. Similarly, we're looking always for anomalies and differences in behavior, and that could be indicative of some hardware that's about to fail. So suddenly, if you've got an optical transceiver that's getting a lot of failures all of a sudden, that could be an indication that that link is about to degrade. And either we can have the data rerouted, or we can signal that there's a preventive maintenance that needs to happen to replace that. And that can apply to other components as well, like GPU failures. If we detect signs that GPU may fail, that's a sign that we don't want to assign a really critical priority workload to that GPU, or assign a long training run to the cluster that GPU is in, because we see signs that it may fail.
So when you take all these actions, a lot of that depends on the latency and the speed of the action. So how does your solution solve for speed?
Yeah, it's a great question, because we are potentially in the critical path for a lot of important control decisions about what's going on in the infrastructure. And conventional BMCs are typically built around standard application processors. And we also have real-time cores in our TCU, as we call it, our Trusted Control Compute Unit. That's the silicon that's part of this intelligent hardware management fabric that we're building. And the TCU silicon with these real-time processors can read telemetry very fast, microsecond latencies, and can take action very quickly as well. If there's something critical like a power event, that something is about to cause a serious power transition in the rack, we can take action very quickly because we're using real-time control. And it's not enough to be fast. That's an important piece of what you need to do. But again, you need to be intelligent, and you also need to be trusted. And that's also part of the picture, is we can do things quickly, but we're also running in trusted silicon that's been attested, that has a very secure root of trust, and is trusted by and knows that it can trust the other components in the system. So the speed, you're absolutely right, is important. The trusted thing is also, the trusted capability is very important. And again, the intelligence that we've talked about. So to really have autonomous infrastructure, you need all three. You need to be fast enough to respond. You need to be smart enough to do the right thing. And you need to be trusted that you haven't been tampered with, because we're talking about millions and millions of dollars of just hardware in a rack, and then millions of dollars in potential losses due to SLAs and loss of training runs. So we have to be something that can really be relied on, and that is known not to be tampered with or altered.
Very interesting. So the trusted autonomous layer for managing the AI infrastructure. Tell me about the future of AI infrastructure, especially as we are going to physical AI, edge AI. How do you see the evolution of your product and this autonomous control layer?
Yeah, it's really great. I mean, the first thing is that really, this autonomy needs to be at all layers of the infrastructure. So starting at the very lowest levels of hardware, where you're looking at an individual chip, a GPU or a CPU, and getting telemetry from that, and seeing what's going on with that chip, up to the tray level, where you have multiple GPUs and CPUs, up to the rack or pod level, which is becoming sort of the unit of compute for data center infrastructure. And then you also need to go up another level and look at autonomy at the fleet level as well. So there's, what we're putting together is a really hierarchical architecture for making all of these levels work together. with our silicon at each level, but also working with other silicon and software products. And we are focusing on your data center, but also your edge AI is becoming important, and the same principles apply. It's interesting with edge AI, you may have lots of smaller deployments that need to be managed, and the autonomy that we're talking about in the data center is arguably even more important at the edge, where you don't have necessarily personnel on site who can take action, where you may have really critical SLAs that need to be maintained at the edge that really don't have the capacity to handle disruptions. So being able to autonomously handle whatever the problem is, a security breach, a failure, or an impending failure, is even more important arguably for edge AI, and that's definitely an area that we're looking at as well.
Yeah. So what does the future of data centers and AI infrastructure look like? And how do you foresee Axiado's role in that future?
Yeah, I mean, the trends are pretty becoming pretty clear. And I think we are seeing that we can help with the challenges that are coming up with the scaling of density, scaling of power, the even more critical need for reliability. So, of course, you were hearing a lot about power in data centers, and data centers are getting larger, and the individual racks themselves are using more power. We've gone from 10 or 20 kilowatts to 10 times that, and maybe even 50 or 60 times that in upcoming generations per rack. So we need to be using power efficiently. That's really important. There's limits on how much power is available now in data centers, and that's often a real restriction in terms of where people can build new data centers. Is there actually power available? So one of the areas that we think we can really help out with is making power usage much more efficient using these intelligent techniques I talked about, running cooling efficiently and scaling voltage and frequency. Also just using the GPUs and CPUs more efficiently in terms of making sure that they're kept busy and not sitting idle, just consuming power without actually providing any value. So we can help with these power constraints. As the density gets higher and higher, where you have more and more expensive equipment in one rack, reliability is important, because now if something happens to anything in that rack that disrupts its operation, it's tens of millions of dollars of equipment that may be out of use and not providing any value. So by helping with reliability and uptime, we can help overcome the costs that come along with this increased density at the rack level. And then the efficiency, again, of the use of this expensive equipment, the more we can optimize how that equipment is used, the more money we're saving operators, in addition to the power savings that we've talked about. So these trends of increased power use, increased density, just increased expense of data centers means that operators have to be just really much more careful about how they're using all this equipment. And we can help in several different dimensions to make sure that operators are getting the most value possible out of their investment in this AI infrastructure.
So when it comes to AI infrastructure, there are the components themselves come from a globally distributed supply chain, and then there are supply side constraints as well. So how does Axiato help the industry deal with those issues?
Yeah, that's another good question. I mean, there's a few different ways we can help. One issue related to supply chain is, as it's getting harder to get components, there's more concern about gray market or resold components that may not meet requirements. So one thing that we do at a very basic level is just a test to the authenticity of components in the rack. So one of the things that would happen during a power-up cycle is the Axiado TCU will go talk to all of the components at whatever level it's at in a server tray or in a rack level, and make sure that those components are authentic, cryptographically attest those. There's some protocols for doing that, and make sure that they're authentic. And then we can create a secure system bill of materials for what's in that rack. And that's something that can be audited and checked to make sure that the equipment that's there is what's supposed to be there. It hasn't been tampered with or replaced when it wasn't supposed to. Things are being pulled out that shouldn't, then being replaced with inferior components. So that's one aspect of supply chain that we can really help with. And another is just, again, as companies are facing these constraints and getting access to GPUs or memory or storage or whatever it is, and we all know the state of things, it's getting harder and harder to get those, and lead times are longer and longer. If you can't get access to more hardware, then you want to take advantage of what you do have as much as possible and use that as efficiently as possible. And that's one of the areas, again, we can help with to make sure that the hardware that's available is being utilized to the full extent possible.
Yeah, very cool. And maybe to sum up, maybe talk about the vision for Axiado and your vision.
Sure. Yeah. I mean, the vision, again, is really, to build AI infrastructure that's intelligent, that's autonomous, that really knows itself and can take action to heal itself or prevent downtime or to deter or prevent attacks. So we have this idea of a intelligent hardware management fabric, which is, again, this hierarchical architecture going from silicon at the very lowest level, at the component level, to the tray or server level, to the rack or pod level, and then eventually to the fleet level, where you have telemetry that's coming from the lower levels and feeding up to the higher levels to aggregate information so that we can make correlations to make intelligent decisions and make that infrastructure autonomous, intelligent, and efficient.
Yeah.
So that's the idea, and we have the silicon and the software and a lot of the pieces to put this vision together, and that's something that we're actively working with companies to deploy. And we'll have more to talk about that in the near future.